Hello there, some supplementary videos here. So earlier we solved remove duplicates, and we had a merge sort and a remove duplicates function. And I believe that we went over these two algorithms pretty quickly without using the UMPIRE method. So I will be creating the UMPIRE methods now. So this one's going to be for the merge sort. So we'll be doing that in LeetCode. And I'll see you there soon. Let's go grab that Safari. All right. So here we go. Let's do the UMPIRE. So in this problem, what we have here is a list of items, and we need to sort them in ascending order. So here are some two cases. We have this item here and this item here. Here's an edge case where we have no items. All right. All right. Let's take a look at the range of items. So we're gonna have a number of nodes. Let's say 50k nodes. That basically means O of n when we're talking 50k. I'm not. Yeah. Once we hit 50k, I think we should just call it O of n. All right. So that's the time complexity, at least, because we do need to go through all the nodes. And the method by which we're going to do it is O of n log n. And how we do that is a merge sort. Why is it going to be n log n? It's because let's say we have n items. Let's say 4 to 1, 3, right? And so how many times do we need to go through this is, well, log n times. So what we're going to do is this is going to be, we're going to split this 4 to 1, 3 into, let's make it one thing first. So now we split it into 4, 2 and 1, 3, split it in half. And we split it in half one more time to make sure that we have all the items that we can split them into multiple lists. With that, we put them back together by a merge, and this is going to be done in ascending order. So with that, as you can see, this tree is 1, 2, 3, 4 now, and we have basically merged these items back together, right? And with that, it will take n log n times because we will have to break it down, and after breaking it down, we'll merge it back together. This is not 2 n log n times because this is part of one function. What I mean by that is that we have one call function. Every time we call make a recursive call. So let's say we do sort list, right? Well, every time we call sort list, we run it. This is one layer. This is another layer, right? So we run sort list here on this function, and basically what happens is that we run sort list twice. You see, here and here at this layer, and then at the next layer we run sort list 4 times. Of course, we have 4, 2, and we have 1 and 3. So with that, then we bottom out the layers back to this, and then back to this particular function, which we return. All right, and I think that's good enough for understanding. Right, the time is O of n log n, and the space is going to be O of 1. I'm not sure if the space is going to be O of 1 because we are doing recursion, and it might be log n space because we are creating these items. Well, actually we're not creating any. We're creating a stack of log of n, and that's how deep the stack goes. Of course, these are pointers to the nodes. So I believe we're doing log n space. It's not O of 1. So I think the way to do this, log of n, O of 1, is to do this in terms of bottom up instead of top down. And I will look into that in the next video. So we'll do, or if we have extra time, we might be able to do it here at this time. So we'll do a match. We're gonna do merge sort, and we'll do a plan. The plan is to, as we've said, separate nodes, split list in half until recursively until single item. That's the base case, and then merge items back in ascending order. That's it, that's the plan. So let's implement it. Okay, so let's move the implementation back up to the top, and so that we have some room to play with. Okay, so define get half. So this is get half of this item, and what we're going to do is point to a list node that we're going to get. And of course, this is a list node type item. With that, let's create a slow and fast pointer. So how does this slow and fast pointer work? Well, we basically have to move the slow half speed of the fast, and we'll just get in the middle, because once the fast reaches the end, we'll have the slow would be, well, in the middle. So that's a pretty simple concept. So let's just do it. Also, we have to run fast.next first and fast.next.next. Otherwise, we'll have a problem, because if fast.next does not exist, fast.next.next cannot exist. That will just cause a, yeah. And do we need fast? What if we have a empty? What if this is a none? What if head is none? Right? That's going to be a problem. Well, half is never going to be none. The reason for that is because we will vet out any item that is none. We're going to return head immediately, and we're not going to get half. So that's why we're not going to have to worry about that. If we do need to worry about fast, we do need to do that instead to protect ourselves. So we do need this line of code like that. Okay, so we'll return slow now. Perfect. With that, we have gone into half, and now we're going to get the next bit, which is the merge. Merge is going to take two lists, list 1 and list 2, and these are going to be list nodes. Of course, this is going to return one list node. So how are we going to merge these items? So first of all, so we just need a list 1 pointer and list 2 pointer. So what we're going to do here is that we're going to create a dummy node, and we're just going to merge these lists together, like we're going to just grab the smaller of the two between, let's say, 1 and 2 and 3 and 4. Let's say we have those two lists. We'll just pull 1, and then we'll point to 2 while this one's smaller, and then we'll just point to the rest once the list node is once list 1 pointer is none. So we can take a look at another video called merge sorted list later, and get a better clue about how that works if you have any questions. I'll also link that into the description of this video. Okay, so let's check that out. Right, so dummy node is equal to the current, which is equal to a brand new list node. So while list 1 pointer and list 2 pointer, we're gonna have to bump these forward. So if list 1 pointer is less than or equal to list 2 pointer, oh, that is it dot value, of course. we're going to set that to list1 pointer. Cur equals cur dot next list1 pointer equals list1 pointer dot next. We're going to set basically the opposites. The question here is, does this have an effect whether we do list1 pointer forward next first, or like, does it matter whether this line and this line is in a different order? I don't think so. So it's completely fine. Okay, with that, we'll take the remainder, like I said earlier, and we'll just attach it to the end. Okay, with that, we have completed all our requisite helper functions, and we are now ready to finish off this question, like how to do this. So first of all, we're going to split the list. So we have list1 equals the head, list2 is equal to the get half of the head, so that's half. Once we have the half, we do need to split the list in half. So let's say we have 1, 2, let's say we have the beginning item 4, 2, 1, 3, right? And we're pointing these items to each other. What we need to do is suppose that we have list1 here, and list2 is here right now, right? What we're gonna do is that we're gonna have to set a temp here and break off this connection, and then reset list2 to be here to break it in half. Okay, so that way we have two separate lists. If they are still attached, then they're not two separate lists. It's one whole list with 2 pointers in the list somewhere. So list2, well, temp is equal to list2 dot next. Another way to do this is just to set it to list2, and that's also will work. And that way we can set this to slow.next to be more accurate. So temp is equal to list2, so that's going to be equal to this part right here at this point, right? And list2.next is equal to none. Nah, it doesn't work, does it? Because if list2 sets this to none, that means we just basically have no pointer to that at all at this point, right? That's completely bogus. Okay, my bad. Let's reverse that. Okay, so we have our list2 here. We're gonna set our temp to be here, and we're gonna break off this connection here. So list2.next equals none. And then we're going to set list2 equals temp. So we broke off this connection, and we have moved list2 to be temped, and now we're ready to continue. So what we're going to do is that we're going to have to continue splitting off these items until they're single items. So list1 and list2 is equal to sort list of list1 and sort list of list2. Okay, that also means that we do need a base case. If not head or head.next is none, then we will return head so that we have that single item. Okay, so with that, let's return the merge between list1 and list2. One way we can make this shorter is to just throw these items in here, but that will just look funky. Okay, so with that, we have solved the problem. Let's see if this runs properly. Right. So the problem was that our functions are outside of, like, was not created before I called these functions. So we do need to move these to the top. Another way to do this is to make sure that they are like outside in the class, but that doesn't really make a lot of sense in terms of coding because these functions are only useful in this area inside this function. That's why they exist. They don't exist anywhere else unless we plan to, like, use them elsewhere. So with that, I think we have the whole code here. What we need to do now is to do a review and to do a evaluation. So let's just review. Let's just grab this item and the empty item because that's the edge case and that's the regular case, and that's all we really need to do. So okay, so how do we do this? So we have this code. We're just looking at this. Okay, so we have 4 points to 2, points to 1, points to 3. Okay, and that points to none at this point. So we'll break the list in half. So let's say we do a slow and fast pointer, which we basically do with the get half function. Of course, at this point, this is list 1. So slow and fast pointer, fast goes twice, and slow goes once. So slow's right here at the 2, and that's what we return. So this is going to be list 2 right now. Okay, so we create the temp. The temp is right here at the 1, and we break off the connection to 1, and we reset 2 to be at temp. All right, so we have broken the item into halves. Those are our pointers. So now we are down at this line of code. We're going to run sort list on these lines of code. Okay, so what that means is that we run sort list on 4 and 2. So basically, we do the same function, 4 and 2. We're going to split it in half, slow and fast, right? And let's just say this is going to be our slow, this is going to be our fast. Fast ends here, and what we're going to do is this is going to be our temp. We're going to break this in half, and this is going to be our list 2, and this is going to be our list 1. Okay. At this point, we have the 1 and 3. 1 points to 3 as well, and the same thing happens. So this is list 1, and this is list 2. Okay. So with that, we run sort list one more time, and basically what happens is that we hit our base case. Head is next is equal to none, and we return the head immediately. So the head is basically return 4, and we return 2, essentially, and we're gonna merge those two lists. So, and we're gonna return 1 and 3. With the merge function, we take the larger of the two, and we're gonna put that item first, and we'll return it. So we have 2 and 4, and 1 and 3. Okay. So with that, we have 1 and 3. So essentially, this layer of code is now gone, and this layer of code is gone as well. So list 1 is now equal to 2 and 4, and list 2 is equal to 1 and 3, and we merge those again. And so that's going to give us a merge between these two. And so basically, we'll take the smaller of the two, and then we shift the pointer forward, right? So we're done with the 1. So the pointer is, here at 3 now. And list 1 pointer is at 2. So we take the 2 and we move the list 1 pointer forward. So we do list 2 and we have 3. And then we do list 1 and we have 4. So that's the merge. And now we have 1, 2, 3, 4. And this layer of the code is done. And we return 1, 2, 3, 4 as our merged list in that particular order. Perfect? Yes. And let's look at the head. So in the head, we have none immediately. We just return it, and we have output is nothing. Okay, so that's what we're done with the review. With that, let's do evaluation. And the time complexity of that is n log n, as we have just shown. We have to log n type items because we split everything in half, and the number of times we can split everything in half is log n. And we have to sort n times every time we do a layer, right? So n log n, and space is log n space because we do have to create the recursive layers. And as time is now 20 minutes, we will be doing the next video in bottom up, and we'll see that later. But let's submit it, and let's go from there. Perfect. All right, I'll see you in the next one.